You're sitting somewhere right now, maybe on a couch, maybe at a desk, maybe walking down the street. And wherever you are, you probably feel like you're somewhere specific, somewhere that has a location relative to other things. You're north of something, south of something else, a certain distance from the center of your city, your country, your continent. Everything has a center, right? Your town has a center. Earth has a center. The solar system has a center, the sun. Our galaxy has a center, a supermassive black hole that everything orbits around. So naturally, you assume the universe has a center too. Some special point, some cosmic downtown, the place where it all began, the spot where the Big Bang happened. And you're wondering, where is it? How far away are we from the center of everything? The universe has no center, not because we haven't found it yet, not because it's hidden or too far away to see, but because center is not a concept that applies to the universe. There is no center. There never was. There never will be. And I'm going to explain to you exactly why. But first, I need to destroy your intuition, because your brain is lying to you about this. Your everyday experience with objects, with rooms, with cities, with planets, has built a model in your head. A model that says everything must have a center. Every sphere has a center point. Every explosion happens at a location. Every collection of things is arranged around some middle. That model works perfectly for everything in your daily life. But it fails completely when you try to apply it to the universe. And understanding why it fails is one of the most profound insights in all of physics. Let me start with something simple, something you can visualize. Imagine you're holding a balloon, not inflated, just limp. You take a marker and you draw dots all over the surface, dozens of dots scattered everywhere. Now you start to inflate the balloon. What happens to the dots? They move apart. Every dot gets farther from every other dot. The balloon expands and the dots spread out. Now, here's the question. As the balloon expands, which dot is at the center of the expansion? Think about it. Which dot is special? Which one is the point that everything else is moving away from? The answer is none of them. Every single dot sees the same thing. Every dot watches all the other dots moving away from it. If you're standing on any dot, it looks like you're at the center, like everything is expanding away from you. But you're not special. The ant on the next dot over sees exactly the same thing. This is called the cosmological principle, the idea that the universe looks basically the same from every location. There's no special point, no privileged position, no center. Every point thinks it's the center, which means no point actually is. Now, you might say, wait. The balloon has a center. I can see it. It's the point inside the balloon, the spot in the middle of the sphere. True, but that's not part of the surface. Remember, in this analogy, the surface of the balloon is the entire universe. The dots are galaxies, and the expansion of the surface represents the expansion of space. The inside of the balloon, the three-dimensional volume it contains, that's not part of the universe. That's not part of space. That's nothing. It doesn't exist in this analogy. For the two-dimensional creatures living on the surface, there is no inside. There is no outside. There is only the surface, and the surface has no center. You can walk forever in any direction on the surface of a sphere, and you will never find a point that's more central than any other point. Every point is equivalent. This is exactly what's happening with our universe, but in 3 dimensions instead of 2. Our entire 3-dimensional space is expanding. Every point is moving away from every other point. And there's no center to that expansion, because every point is equivalent. Now let me tell you about something remarkable. Something we discovered less than 100 years ago. Something that completely changed how we understand the cosmos. In the 1920s, an astronomer named Edwin Hubble, not the telescope, the man the telescope was named after, made a series of observations that shocked the scientific world. He looked at distant galaxies. He measured their light, and he discovered something incredible. The galaxies are moving away from us, not just one or two, all of them. Every galaxy we can see is receding, getting farther away. And here's the kicker. The farther away a galaxy is, the faster it's moving. A galaxy twice as far away is moving twice as fast. A galaxy 10 times farther. This is called Hubble's law, and it's one of the most important discoveries in the history of science. Now, when people first hear this, they think, oh, we must be at the center. Everything is moving away from us. We're special. We're at the middle of the universe. But no, that's exactly wrong. Remember the balloon. Every dot on the balloon sees every other dot moving away. The expansion of space creates the illusion that you're at the center, no matter where you are. If you lived in a galaxy a billion light-years away, you'd see exactly the same thing. All the galaxies moving away from you, including our galaxy, the Milky Way. You'd measure the expansion. You'd discover Hubble's law, and you'd see yourself as stationary with everything else receding. The observation that everything is moving away from us doesn't mean we're at the center. It means the universe has no center. It means space itself is expanding uniformly. Every point is equivalent. This is hard to accept. Your brain fights it. You want there to be a center. You want there to be a special location. But the universe doesn't care what you want. Let me give you another way to think about this. Imagine an infinite sheet of graph paper, perfectly flat, extending forever in all directions. No edges. Now imagine that every hour, the spacing between the lines doubles. The grid squares get bigger. Every intersection point on that graph paper is getting farther from every other intersection point. If you're standing at any intersection, you watch all the other intersections move away from you. The ones twice as far move twice as fast. The ones 10 times farther move 10 times faster. Now, where's the center of this expansion? There isn't one. Every point is equivalent. Every point sees the same thing. The expansion is happening everywhere at once. There's no special location where it started. No central point. This is what's happening in our universe. Space is expanding uniformly. Every point is moving away from every other point. And there's no center because the expansion is a property of space itself, not an explosion happening at a location. Okay, but what about the Big Bang? Surely the Big Bang happened somewhere, right? There's a point in space where the universe began. A location we could point to and say, there, that's where it all started. No. This is the most common misconception about the Big Bang, and it's completely wrong. The Big Bang did not happen at a point in space. The Big Bang happened everywhere. Let me say that again because it's crucial. The Big Bang did not happen at a location. It happened at every location simultaneously. 13.8 billion years ago, every point in space was in the same state. Infinitely hot, infinitely dense, rapidly expanding. There was no center to that state, no special point. Every point was equivalent. And as space expanded, every point cooled, every point thinned out, every point evolved in the same way. Think about it this way. When you trace the expansion of the universe backward in time, you don't converge on a point in space. You converge on a moment in time. The Big Bang is not a place, it's a time. It's the moment when space was in that hot, dense state. And that moment happened everywhere. If you could rewind the history of the universe, you wouldn't see all the galaxies rushing toward a single point somewhere out there in space. You'd see all of space shrinking, every point getting closer to every other point, until every point is on top of every other point. Not at a location, but everywhere. The Big Bang is not an explosion in space. It's an expansion of space. Space itself came into existence in that event. Or more accurately, space as we know it, with its current properties, emerged from that state. And because space itself is what's expanding, there's no outside, there's no center. There's just space everywhere, all at once. Now, let me address something you're probably thinking. Okay, fine, maybe there's no center in the observable universe. But the universe is bigger than what we can see. Maybe the center is out there, beyond our horizon. Maybe we just can't see it. Here's the problem with that. The universe is either infinite or it's finite but unbounded. Those are the options. And neither option has a center. If the universe is infinite, then it extends forever in all directions. And an infinite space has no center. You can't find a middle point in something that goes on forever. Every point is infinitely far from the edges because there are no edges. If the universe is finite but unbounded, like the surface of a sphere, then it wraps around on itself. And we already covered this. A sphere's surface has no center point on the surface. You can walk forever and never find a spot that's more central than anywhere else. Either way, center doesn't apply. Not because we're ignorant, not because we lack information, but because the geometry of the universe doesn't have that property. Now watch this. I'm going to show you something beautiful, something that connects all of this together. Einstein's general theory of relativity, the same theory that tells us about curved space-time, also tells us about the universe as a whole. And built into that theory is the cosmological principle, the idea that the universe is homogeneous and isotropic. Homogeneous means it's the same everywhere. If you look at a large enough volume of space, it has the same average density, the same properties, as any other large volume. There's no special region. Isotropic means it's the same in all directions. If you look north, south, east, west, up, down, you see the same kinds of structures, the same distribution of galaxies. There's no preferred direction. These two properties together, homogeneity and isotropy, mathematically forbid a center. If the universe has a center, then the center is special. It's a unique point. And that violates homogeneity. If the universe has a center, then there are preferred directions, toward the center and away from the center. And that violates isotropy. So the very structure of our best theory of the universe, the theory that's been tested and confirmed countless times, tells us the universe has no center. This isn't speculation. This isn't philosophy. This is built into the mathematics of reality. And we've tested it. We've looked at the cosmic microwave background, the leftover radiation from the Big Bang. We've measured its properties in every direction. And guess what? It's the same everywhere. Same temperature, same fluctuations, same structure, no matter which direction you look. We've mapped the distribution of galaxies across billions of light years, and on large scales, it's uniform. Same density, same clustering patterns, same everything. There's no center, there's no edge. There's just space, filled with matter and energy expanding uniformly. Here's where people get confused. They think expansion needs a center. They think if things are moving apart, they must be moving apart from something. But that's only true for an explosion in space, for objects moving through a pre-existing space. But the expansion of the universe isn't objects moving through space. It's space itself expanding. The galaxies aren't flying away from each other through space. The space between them is growing. Think of it like this. Imagine two coins glued to a rubber sheet. You stretch the rubber sheet. The coins get farther apart. But the coins didn't move relative to the rubber. The rubber itself stretched. That's what's happening with galaxies and space. The galaxies are embedded in space. And as space expands, they get carried along. They're not moving through space. Space is expanding and taking them with it. And because space is expanding everywhere uniformly, there's no center to the expansion. Every point in space is expanding away from every other point at the same rate. Now, I need to tell you about something that makes this even stranger. The expansion of the universe is accelerating. We discovered this in the 90s. Two teams of astronomers studying distant supernovae realized that the universe isn't just expanding, it's expanding faster and faster. Something is driving the expansion. We call it dark energy. We don't know what it is. We don't understand its nature. But we know it's there because we can see its effects. And here's the thing. Dark energy is uniform. It's the same everywhere. It's not concentrated at any point. It's not pushing from a center. It's a property of space itself. Every cubic meter of space has the same amount of dark energy, and that energy is causing space to expand. Everywhere, uniformly, with no center. This makes the no center property even more fundamental. Not only is there no center to the matter distribution, there's no center to the dark energy. There's no center to the expansion. There's no center to anything. The universe is the same everywhere you go. Let me give you one more way to think about this. One more analogy that might help. Imagine you're inside an infinite loaf of raisin bread. The dough is rising. The bread is expanding. You're sitting on one raisin. Every other raisin is moving away from you as the dough expands. The farther away a raisin is, the faster it's receding, because there's more dough between you expanding. Now, where's the center of this loaf? There isn't one. The loaf is infinite. It goes on forever, in all directions. Every raisin sees the same thing. Every raisin watches all the others move away. No raisin is special. No raisin is at the center. That's our universe. We're one of the raisins. Space is the dough. And the dough is expanding everywhere at once. No center, no edge, just expansion. Now, you might be wondering, okay, I get it mathematically. I understand the analogy, but emotionally, this feels wrong. How can there be no center? How can the Big Bang have happened everywhere? My brain can't picture it. Good. That's the correct response. Your brain can't picture it because your brain evolved to understand objects in three-dimensional space. It didn't evolve to understand the geometry of space itself. You can visualize a sphere, you can imagine its center, but you can't visualize a three-dimensional space that's uniformly expanding with no center because you're trying to picture it from the outside. And there is no outside. You're inside it. You're part of it. There's no external perspective from which to view the whole thing. This is the same problem we talked about with the bug on the balloon. The bug can't visualize the balloon from outside. The bug is stuck on the surface. And we're stuck in three-dimensional space. We can't step outside and look at the shape of the universe. We can only measure it from within. And when we do, the measurements tell us there's no center. Here's something Richard Feynman, one of the greatest physicists of the 20th century, understood deeply. You don't need to visualize something to understand it. You don't need a mental picture for it to be true. What matters is the mathematics. What matters is the predictions. What matters is whether the theory matches reality. And our theory of a centerless, uniformly expanding universe matches reality perfectly. It predicts the redshift of distant galaxies. It predicts the cosmic microwave background. It predicts the abundance of light elements. It predicts the large-scale structure of the cosmos. Every prediction matches observation. The theory works. The universe has no center, not because we can't find it, but because that's not how the universe is structured. Now, let me tell you about something subtle, something that trips people up. When we say the universe has no center, we're talking about the universe as a whole, the distribution of matter and energy on the largest scales. But obviously, individual things have centers. The Earth has a center. The Sun has a center. Our galaxy has a center. Those are real. Those are measurable. You can point to the galactic center. You can calculate the Earth's core. But those are local structures. Those are clumps of matter that have gravitationally collapsed into bound systems. They have centers relative to themselves. The Earth's center is the middle of the Earth. The galaxy's center is the middle of the galaxy. But the universe as a whole doesn't have a center relative to itself because the universe as a whole is everything. There's nothing to be in the middle of. When you ask, where is the center of the universe, you're asking, what point in the universe is equidistant from the edges of the universe? But the universe has no edges. So the question doesn't make sense. It's like asking, what's north of the North Pole? The question assumes something that doesn't exist. Here's the key. On small scales, gravity dominates. Gravity pulls things together. It creates structures with centers. Galaxies, stars, planets, all held together by gravity. But on the largest scales, the cosmological scales, expansion dominates. The space between galaxy clusters is growing, and that expansion is uniform. It's the same everywhere. It has no center. So the universe is lumpy on small scales and smooth on large scales, and the smooth, large-scale universe has no center. This connects to something deep about the nature of space and time. Einstein taught us that space and time are not fixed, absolute things. They're dynamic. They're part of the fabric of reality, and that fabric can bend, stretch, expand, contract. When we say space is expanding, we mean the fabric of space-time itself is growing. The distances between points are increasing, not because the points are moving, but because the space between them is stretching. And this expansion doesn't have a center because space isn't expanding into anything. Space is everything. It's not growing into some pre-existing void. It's just expanding. More space is being created between every pair of points, uniformly, everywhere, with no center. Let me tell you about a thought experiment. Imagine you could freeze the universe. Stop the expansion. Capture a snapshot of all the galaxies, all the matter, all the energy. Now you analyze that snapshot. You measure the positions of every galaxy. You calculate the density of matter in every region. You look for patterns. What you'd find is that on large scales, everything is uniform. The density is the same everywhere. The distribution is the same in all directions. There's no gradient, no flow toward a center, no thinning out toward an edge, just uniformity. And from that uniformity you conclude there's no center, because a center would create asymmetry. It would create a special point, and there's no special point. Every point is the same. This uniformity is not a coincidence. It's not a lucky accident. It's a fundamental feature of how the universe works. It's built into the laws of physics. It's a consequence of the symmetries of space-time, and we've confirmed it with observation after observation. Now, here's something that blows people's minds. If the universe is infinite, then it was always infinite. Even at the Big Bang, think about that. At the moment of the Big Bang, space was infinitely large, but it was also infinitely dense. How is that possible? How can something be infinite and still expand? Here's how. Infinity doesn't mean big. Infinity means without bound. An infinite space can still have every point getting farther from every other point. The distances grow, the density decreases, but the space remains infinite. Imagine the infinite number line, all the integers, negative infinity to positive infinity. Now multiply every number by 2. The spacing doubles. 1 becomes 2, 10 becomes 20, 100 becomes 200. The distances between numbers have increased, but there are still infinitely many numbers. The line is still infinite. That's what's happening with an infinite universe. It's expanding, but it remains infinite. And because it's infinite, there's no center. You can't find the middle of infinity. Every point is infinitely far from non-existent edges. Now, if the universe is finite, it's finite in a very specific way. It's closed. It wraps around on itself like the surface of a sphere. And we already covered this. A closed surface has no center on the surface. So either way, infinite or finite, there's no center. The geometry forbids it. Here's what I want you to take away from this. The universe is not a thing sitting in space. The universe is space. And space is not a container. Space is a dynamic, evolving fabric that's the same everywhere. When you look at the night sky, you're not looking out from some location toward the edge. You're looking at a uniform cosmos that extends in all directions with no preferred point. And you, wherever you are exactly as central as everywhere else, which is to say not central at all. This is one of the most profound realizations in all of science. The Copernican revolution told us we're not at the center of the solar system. The Hubble discovery told us we're not at the center of the galaxy, and the cosmological principle tells us we're not at the center of the universe. Because there is no center of the universe, we've been demoted from the center of everything to just another point in an infinite or unbounded cosmos. And somehow, that's more beautiful than being special. Because it means the universe is democratic. Every point is equivalent. Every observer sees the same large-scale structure. The laws of physics are the same everywhere. There's a unity to it, a symmetry, a deep, profound sameness. And that sameness is what allows us to do cosmology. If every point in the universe obeyed different laws, if there were special locations, we couldn't make predictions. We couldn't extrapolate. We couldn't understand anything beyond our local neighborhood. But because the universe is homogeneous and isotropic, we can measure things here and know they apply everywhere. We can look at distant galaxies and trust that the physics is the same. We can build models of the entire cosmos based on observations from one tiny corner. That's the power of the cosmological principle. That's the gift of a centerless universe. Now, I want to address one more thing. One more question that people ask. If there's no center to the universe, does that mean we're not special? Does that mean there's nothing unique about our location? In a cosmic sense, yes. Our location is ordinary. We're in a typical galaxy. In a typical region of space. There's nothing cosmologically special about where we are. But that doesn't mean we're not special in other ways. The fact that we're here, that we exist, that we can ask these questions, that's extraordinary. The fact that the universe is structured in a way that allows for complexity, for stars, for planets, for life, for consciousness, for beings who can figure out that the universe has no center. That's remarkable. We're not special because of our location. We're special because of what we are. Thinking matter, the universe examining itself. And from our ordinary location in this centerless cosmos, we've figured out the shape of everything. We've measured the expansion. We've traced the history back to the Big Bang. We've discovered that space itself is the thing that's growing. We've realized that there's no center, no edge, no outside, just space, uniformly expanding, filled with matter and energy, evolving according to the laws of physics. That's the universe, centerless, edgeless, uniform on the largest scales, and we're part of it. Not at the middle, not at the edge, just somewhere, everywhere. Equivalent to every other point. Here's the final thought I want to leave you with. The question, where is the center of the universe, comes from a misunderstanding of what the universe is. It treats the universe like an object, like a ball that has a middle point. But the universe is not an object in space. The universe is space, and the properties of space, its geometry, its expansion, its uniformity, those properties don't include a center. The question dissolves when you understand what you're actually asking about. This happens in science. Sometimes a question that seems profound turns out to be based on a misconception, and when you fix the misconception, the question goes away. What's outside the universe? Nothing, because outside doesn't apply. What happened before the Big Bang? The question might not make sense, because time itself began at the Big Bang. Where is the center of the universe? Nowhere, because the universe has no center. These aren't failures of knowledge. These are clarifications of what the universe actually is. And that's beautiful. That's understanding. Not just collecting facts, but grasping the deep structure of reality. Seeing that the cosmos is stranger and more elegant than our intuition suggests. We are creatures living in a centerless, expanding, uniform universe. A universe that obeys the same laws everywhere. A universe that we can understand through mathematics, observation, and reason. A universe that doesn't need a center because every point is equivalent. And somehow, impossibly, we figured this out. We're the universe understanding itself. And what we've discovered is that we're not at the center. We're everywhere and nowhere. Part of a vast, centerless expanse. And that's exactly where we should be. Let me dig deeper into why this matters, why understanding that the universe has no center changes how we think about everything. Because this isn't just an abstract fact, it has real implications for how we understand the cosmos. First, it tells us something about the Big Bang. When people imagine the Big Bang, they picture an explosion. A point that detonates and sends matter flying outward in all directions, like a bomb going off. And if that were true, there would be a center, the spot where the bomb was, the location of the explosion. But that's not what happened. The Big Bang was not an explosion in space. It was the beginning of space itself. Every point in the universe was part of the Big Bang. There's no location you can point to and say, there, that's where it happened. It happened here, it happened there. It happened everywhere, simultaneously. This completely changes the picture. It means the Big Bang is not something we're moving away from. It's something we emerged from, and every point in space emerged from it equally. Second, it tells us about the fate of the universe. If the universe had a center, you'd expect the expansion to be different at different locations. Things near the center might behave differently than things far from the center, but because there's no center, the expansion is the same everywhere. The universe is expanding uniformly, and that uniformity determines its future. If dark energy continues to dominate, the universe will expand forever. Every galaxy will eventually be so far from every other galaxy that they'll be beyond each other's observable horizons. The universe will become cold, dark, empty, but there will still be no center. Every point will remain equivalent. If gravity somehow overcomes dark energy, which seems unlikely given current observations, the universe could stop expanding and start contracting. Everything would get closer together, but again there would be no center to the contraction. Every point would be moving toward every other point, uniformly, everywhere. The geometry forbids a center in expansion or contraction. Third, it tells us about the possibility of other universes. Some theories suggest our universe might be one of many, a multiverse. Each universe potentially with different properties, different laws of physics. But here's the thing. Even in a multiverse, each individual universe would still have no center. A cosmological principle would still apply within each universe. Each one would be homogeneous and isotropic. Each one would be centerless. The multiverse as a whole might have some structure, some distribution of universes. But we can't observe that. We can only observe our universe, and our universe has no center. Now, let me address something technical, something that physicists actually measure to test this idea. We look at the cosmic microwave background, the CMB. This is the oldest light in the universe, radiation that's been traveling through space for 13.8 billion years. It comes from a time when the universe was only 380,000 years old, when space was filled with hot plasma that suddenly became transparent. And here's what's remarkable about the CMB. It's almost perfectly uniform. The temperature is the same in every direction, to within 1 part in 100,000. There are tiny fluctuations, tiny variations in temperature. And those fluctuations are incredibly important. They tell us about the seeds of structure in the early universe, the tiny density variations that eventually grew into galaxies and clusters. But the overall pattern of those fluctuations is the same everywhere. There's no preferred direction, no gradient toward a center, no indication of any special location. The fluctuations are random, distributed uniformly across the sky, and that uniformity is exactly what we'd expect from a centerless universe. If the universe had a center, we'd see it in the CMB. There would be a pattern, a directionality, some indication of a special point. But there's nothing, just beautiful, uniform randomness. This is one of the most precise confirmations of the cosmological principle we have. The universe is the same in all directions. And if it's the same in all directions from our location, and the laws of physics are the same everywhere, then it must be the same in all directions from every location, which means there's no center. We've also measured the distribution of galaxies. Massive surveys that catalog millions of galaxies across billions of light years. And when you look at the data, you see structure. Galaxies cluster together. They form groups, clusters, superclusters, enormous filaments of matter separated by vast voids. It's beautiful. It's complex. It's structured. But here's the key. That structure is random. It's the result of gravity amplifying tiny fluctuations over billions of years. And the pattern of that structure is the same everywhere. There's no gradient, no flow toward a center, no thinning out toward an edge. On scales of hundreds of millions of light years, the universe looks the same in every direction. This is called the scale of homogeneity. The scale at which the universe stops looking lumpy and starts looking smooth. And that scale is the same no matter where you are. Again, no center. Every point sees the same large-scale structure. Let me give you one more piece of evidence, something called the Hubble constant. This is the rate at which the universe is expanding, the number that tells you how much faster distant galaxies are receding based on their distance. We measure the Hubble constant by looking at galaxies in all directions. Near galaxies, far galaxies, galaxies to the north, to the south, in every direction. And what do we find? The Hubble constant is the same everywhere. The expansion rate doesn't depend on direction. It doesn't depend on distance beyond the linear relationship. It's uniform. If the universe had a center, the expansion would be different in different directions. Things moving away from the center would behave differently than things moving toward it. But we see no such effect. The expansion is perfectly isotropic, the same in all directions. This is powerful evidence that there's no center. The universe is expanding uniformly, and uniform expansion has no central point. Now, here's the philosophical implication. There's a long history of humans thinking we're at the center of things. Ancient cosmologies placed Earth at the center of the universe. Copernicus showed that Earth orbits the Sun. Then we discovered the Sun is just one star among billions in our galaxy. Then we learned our galaxy is one of hundreds of billions. And now cosmology tells us there's no center to the universe. At all, we've been progressively demoted from the center of everything to just another point in the cosmos. But that's profound. It means we're not burdened with cosmic significance in terms of location. What makes us special is our ability to figure this out, to understand that the universe has no center, to measure the expansion, to trace history back to the Big Bang. That's the real achievement. Richard Feynman understood this. He cared about truth. The universe is under no obligation to make sense to your intuition. The universe is what it is. Feynman would tell you to stop trying to picture the universe as a thing in space. It's not. It's space. And space doesn't have a center, because center is a property of objects, not of space itself. The mathematics matters. The equations of general relativity describe an expanding, homogeneous, isotropic universe. Those solutions don't have a center. The geometry forbids it. Trust the math. Trust the observations. The universe is vast and strange and beautiful, and it doesn't have a center. This connects to the Feynman equations, solutions to Einstein's field equations that describe how the universe evolves. Built into those equations is the assumption of no center. Every point in space expands away from every other point at the same rate. No special location, no central point, and those equations match reality. They predict the expansion, the cosmic microwave background, the formation of structure, which means the universe really is centerless. Not philosophy, physical fact. The centerless nature connects to dark energy, the cosmological constant Einstein added to his equations. It's real. It exists, and it's uniform everywhere. Every cubic meter of space has the same amount. No center, no concentration at any point. A property of space itself, everywhere, equally. This is the reality of the cosmos. Every galaxy's motion, every expansion of space, all happening in a universe with no center, and that's the truth. That's what the evidence shows. That's what the mathematics predicts. The universe has no center. It never did. It never will. And understanding that is one of the great achievements of human thought. We're tiny creatures on a tiny planet. And we figured out the shape of everything. We discovered that the universe is centerless, that every point is equivalent, that space itself is expanding. We did this through observation, measurement, mathematics, and reason, by letting go of intuition and trusting evidence, by accepting that the universe is stranger than we imagined, and now we know. The universe has no center, and that's beautiful.